The Algebra 2 11.1 video notes. First, we're going to define a sequence. A sequence is an ordered list of numbers. All right, on example 1, it wants us to write the first 6 terms of this sequence. They give us 2 sequences here, actually. So first, we're going to do this. They're just written slightly different. So if we want to do this sequence, if I plug in 1 to find the first term, A sub 1, the little 1 just means first term. You plug in a 1 for n. N means which number of term you're on. So 2 times 1 plus 5 is 7. So to find the second term, you plug in 2. 2 times 2 plus 5 is 9. The third term, you plug in 3. 2 times 3 plus 5 is 11. So you have 7, 9, 11. You probably don't have to plug in more to find the remaining 3 terms. You can tell the pattern is that they're going up by 2s. And so you can just list them off. Those are the first 6 terms in this sequence. All right, so if we look at this other notation, this is function notation here. And very similar, if I want to find the first term, I plug in 1 for n. N just tells you which number of term you're on. So you get -3 to the 0, which is just 1. So for the second term, I plug in 2. 2 minus 1 is 1. So I have -3 to the 1 power, which is -3. The third term, I plug in 3. 3 minus 1 is 2. So that's -3 squared, which is 9. Fourth term, I plug in 4. I get -3 to the third power, which is -27. And you can keep going. Your remaining terms are 81 and -243. But you just plug in 1 for n, 2 for n, so on to find the first 6 terms. Okay. Example 2 says, describe the pattern, write the next term, and then write a rule for finding the nth term of the sequence. So we're looking for a pattern here. When I'm looking for a pattern, kind of how I think about it is I think about the first term is -1. This is n, which is like first term. The second term is -8. The third term is -27. The fourth term is -64, and so on. And I write it like that because I'm just trying to find connection. So when I'm looking at this, I see that they are negative. And then I also see that this is the same as 1 cubed, 2 cubed, 3 cubed, 4 cubed, except they're negative. So what I think is happening is they're plugging in, making it negative, and then cubing it. So I think that is the pattern. Like the next one should be -5 cubed would be -125. That would be the next number in the sequence. And I think this rule would work. And you can always check it out by plugging back in 1, 2, 3, 4, and so on. Now, the thing about this is there's not just one way to do it. I know typically you guys prefer when there's just a, this is what you do every time, recipe to solve. But sequences and series are hard because even if there's a pattern, sometimes it's hard to explain what the pattern is and see it. And that's what we're going to see here on this next one. So think of this one as, just like we did before, I think that as the first term is 0, the second term is 2, the third term is 6, the fourth term is 12. Now, this one was kind of hard for me to figure out. I just kind of had to start working at it. So thinking about, like, I just didn't start with the 0 because honestly, I just thought, well, that's probably 0 times something. So if I kind of look at this, what I noticed was, for example, on the 6, that would be 2 times 3. And on the 12, that would be 3 times 4. So kind of working backwards, the 2 would be 1 times 2 and 0 times 1. So do you see the pattern? It goes 0 times 1, 1 times 2, 2 times 3, 3 times 4. So the fifth term is probably going to be 4 times 5, which is 20. Now, explaining how this is happening is a little bit harder. And so remember that this is n. So each time I'm taking the n times the number before it. So how I write that is I have n, and then the number before n is n minus 1. And that would be my rule. And I could write it like f of n or a sub n, it doesn't matter. Both of these are the same thing. And you could distribute the n and get n squared minus n. To me, I kind of think about it this way. Like I said, that's what makes this difficult, is that not everything falls in a perfectly easy to identify rule. You're going to have to think out of the box and really persevere, because sometimes it doesn't just come to you quickly. All right, on example 3, when you work in a grocery store and you're stacking apples in the shape of a square pyramid with 7 layers, okay? Write a rule for the number of apples in each layer and then graph the sequence. So think about this. Layer 1 just has 1 apple. Picture you have 1 apple. The second layer has 4 apples, and then that other one's on top in the middle. So the second layer has 4. The third layer would be with 9 apples, because if this makes sense, the other 4 would be resting in between them like that. So the third layer would have 9 apples, and the fourth would have 16, and so on. So when I look at these, I see that these are 1 squared, 2 squared, 3 squared, 4 squared, and so on. So my rule is n squared. All right, and so my numbers, if I kept going, 5 would be 25, 6 would be 36, 7 would be 49. They want me to graph the sequence. So down here, I just need 1 through 7. And you can number them all or just every couple. And then I need to go up to 49 on the y-axis. So I went by 5s. So I have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, so if I graph this, I have a point at 1, 1, that's down here, 2, 4, 3, 9, 4 was at 16, 5 was at 25, 6 was at 36, and 7 was at 49. And you can see this does not form a line. This forms a curve, which is just a different type of sequence. All right, so now let's talk about series. A series is when the terms of the sequence are added together. All right, and so we are going to talk about sigma notation. And so sigma is a Greek letter that looks like this. And so on the bottom, we usually use I, and we put I equals 1. That just means we're starting with the first term. And on the top, there can be a number there. And then there can be some type of equation in here. It could be 2i or I plus 4 or 3i minus 8. It doesn't matter, just some type of an equation. Now, if there is a number on top, then it is finite, meaning it has an end. So what that means is we're adding up term 1, term 2, term 3, and term 4. So it ends. But it could also have, instead of a number on top, it could have an infinity on top. And that means it goes on forever. So it is an infinite series. All right, so these are pretty easy to figure out, because when you look down here, you see how this ends at 250. So it is a finite series. And you see how this one has a dot, dot, dot. That means it continues on. So it's infinite. Okay, so to figure out our series, this is term 1 right here. And so we are starting with I equals 1. Now we need to find our pattern. It goes 25 to 50 to 75. So it's adding by 25 each time. So now it's tempting to pit like I plus 25. That's not quite right. Okay, look at your numbers. Term 1 is 25. Term 2 is 50. Term 3 is 75. So you need to write it in terms of, if I plug in 1, I'm going to get 25. So that'd be 25 times I, because 25 times 2 would be 50, 25 times 3 would be 75, and so on. So what term is 250? 25 times what is 250? It's 10, it's the 10th term. So this says I'm adding, sigma means sum, I'm adding up terms 1 through 10 in this pattern 25i. Okay, so let's look at this one. This one is going on forever, so I can start with 1, but put infinity up here. But now you've got to find your rules. So we've got to figure out what's happening. So if you think about this as term 1, term 2, term 3, term 4, you see those numbers match on the top. So the top is just I. The bottom numbers, 2, 3, 4, 5, they're 1 up. So the bottom is I plus 1. So we want to say we're adding up from 1 to infinity, I over I plus 1. All right, on example 5, we actually want to find the sum. You see here, it starts at 4 and it ends at 8. So if you find the 4th term, it'd be 3 plus 4 squared, and that's 19. You're welcome to use a calculator. The 5th term, 3 plus 5 squared, would be 28. 6th term would be 39. The 7th term would be 52. And the 8th term would be 67. So this means you add up all of those terms. You're going to do 19 plus 28 plus 39 plus 52 plus 67. And so you get 205. So we're really focusing today on being able to read, like this is where you're starting, the top number is where you're ending, this is the pattern, and the sigma means add them all up. Okay, examples, series formulas. Okay, here's 3 formulas. We would definitely want to have these on our note cards. So if you want to do the sum of n terms of 1, this one seems obvious, but it's going to like lead to our other formulas. So what I mean by that is if you have like 5 terms of 1, that means you have like 1, 1, 1, 1, 1, like 1 written 5 times. So what you do is you literally have the answer is however many terms you have. So if you want to add up 1 7 times, that would be 7. You want to add up 1 100 times, that would be 100. Now, that's kind of silly, but here's where it's important. If you want to do the sum of the first n positive integers. All right, so for example, 1 plus 2 plus 3 plus 4 plus 5 plus 6, so on, okay? Here's the formula for that, because if it's a small amount, you might just add them up. But what if I asked you to add up like the first 1 through 70? That would be a real pain to type in your calculator. But there's a formula. You do n times n plus 1 divided by 2. So if I wanted to add up like 1 through 70, I'd use 70 for n times 70 plus 1 divided by 2. And that would get me the answer without me having to do that. Now, if you want to do the sum of squares of the first n positive integers. So what I mean by that is think about your square numbers like 1, 4, 9, 16, 25, 36, so on. If you want to add those up, here's the formula. You have I equals 1, and then you end on n, however many integers you're adding, and it's I squared because they're square numbers. So the formula is n times n plus 1 times 2n plus 1, all divided by 6. All right, so where this comes into play, this says how many apples are in the stack in example 3. Well, if we go back and look at example 3, we had down that it was n squared. So we're going to use this I squared formula because that's the pattern the numbers are in. They go 1, 4, 9, 16, so on. So keep in mind there were 7 stacks. So I'm going to do the sum from 1 to 7 because I want all 7 stacks of I squared. So my n is 7 because of 7 stacks. So I do n, which is 7, n plus 1, so 7 plus 1, 2 times n plus 1, so 2 times 7 plus 1, all over 6. So I have 7 times 8 times 15 all over 6. And that gets me 140. So in that grocery store example, to do this pyramid using 7 like layers of apples, we would need 140 apples.